Hello everyone. Welcome to Simulation. I'm your host, Alan Sakian, and today we have the pleasure of sitting down with Andra Keay.
It's a pleasure to be here.
Hello, hello.
Hello.
Happy Women's Day.
I was saying, for me, Women's Day, it's 365 days of the year, so, hurrah.
Hoorah. We have a great show coming up, a great conversation. Andra is the managing director of Silicon Valley Robotics. She's an investor, an advisor, and a robotics ethicist. So this is going to be some great conversation about our future with robots. Actually, just a couple minutes ago, you taught me that 75% of all robots are in places that humans don't even see them. We don't even engage with them in those positions.
Well, it's a mix. Either we don't see them, which is where a large part of the world's robots are today, or they're in places where we might see them, but we don't necessarily have contact with them, or we don't even necessarily recognize that they're robots. One of the things about robotics is that aside from the humanoid robot, which is kind of the apex in terms of the pyramid of robotics, and that's the one that we've all grown up wanting to have, the rest of what is a robotics technology, it's improving and advancing all the time. So today we're surrounded by things that 50 years ago we would have called robots, but now they're just what we expect from our products. They're smarter products.
So let's unpack this more, because for me, I think a relatable example is when we get things shipped to us from Amazon.
Yep.
Typically we don't think about the actual warehouse and the little Kiva robots that are driving around the warehouse, picking up the packages, bringing them over to the actual workers that end up doing the rest of the process. That's one of so many examples of where we don't actually interact as consumers.
That's a great example, because that's a very recent development in robotics, and the large part of robotics history, and robotics has been an industry for over 50 years. From the early 1960s, the first commercial robot arm was developed by Engelberger, and the next iteration of that one kind of, trying to get the order of dates correct, but I think GE picked up on that, and it became, the next iteration of Unimate was the programmable robot universal machine from Stanford. This was actually developed here at Stanford, and that was done by Vic Scheinman, who, and it became known as the Puma arm. So it was programmable universal machine for assembling, I believe, if we get it correct. And that was the first kind of electronically programmable robot arm, and it's formed the basis of pretty much the majority of the robot industry up to today. And those are the industrial robot arms, and they are kept, generally speaking, in cages or in factories, which are kind of lights out factories. They do not have the smartness or the sensors to detect if they're going to have some sort of collision with people. And yet they have been what's underpinned productivity in the automobile industry, in consumer electronics assembling, and in difficult and dangerous materials handling. So they do a lot of things like welding, robot welding, and molten materials, molten metals handling. And the key principles for robotics have really stemmed from those days, which are that robots should be doing the dirty, dull, and dangerous tasks. Now, what's happened in the last 50 years, and it's all really kind of coming to a tipping point in the last just 5 years, really, 5 to 10 years, has been that these really expensive, complex robot technologies, and I will add that the other areas that those technologies have been used have been what we call the service robotics industry sector. So we've had industrial robots, and then the service industry has covered things like Intuitive Surgical, which has developed the very complex robot arms for surgery. And so a few people see them, but they're very highly trained, and as a consumer, you won't be aware of that because you're going to be out cold under anesthetic when you're having the operation done. And the other, perhaps most widely distributed robot is one that I just love. It's the dairy milking machine for dairy farms. And this has been pretty much fairly well developed over the last 20 years. And now countries like the Netherlands and New Zealand are using not just the robotic milking machines, which is a very intelligent ability to, kind of attach pumps and monitor the freshness and the quality of the milk, but also the way that you get cows in and out of the milking areas, and that extends into things like automatic gates, back scratchers, and automatic feeders, so you can pretty much design a pathway for the cow. Not only that, but the cow can pick their own pathway in a lot of these instances. So when you've got one of the fully roboticized dairy farms, some of the things that they've found in studies are that the cows are happier and they're producing twice as much milk.
Wow.
Because with human labor, we're really limited to milking twice a day. And it turns out if a cow is producing a lot of milk, they're quite uncomfortable and they would happily milk more frequently. And then when they're milking that frequently, they can eat richer food. So generally speaking, allowing the cow to choose when they care to get milked makes them feel happy, more comfortable, they eat better, they produce more milk, so you get a real virtuous cycle in productivity.
And when they have the back scratcher going on, I'm sure
if
Ron or I had a back scratcher going on us while we were doing our performance here, our exercise, we would be performing twice as much.
It would be done, or in fact the entire show would be in front of the back scratcher. So you can,
Yes, back scratcher. That's good. That's good. So we just covered all the way from automobiles.
That's pretty much taking us up to today. And the next area that's seen a lot of change and growth has been autonomous vehicles. Since the DARPA Robotics Challenges, and the DARPA Robotics Challenges were designed to bring a technology forward to say, look, it's easily 20 years out. It's not investable. No investor is going to stretch more than a 5 to at max 10-year kind of time frame. So what can the government do to bring technologies that we're going to need further forward and get them to the point where they're going to be commercial? So the first DARPA Robotics Challenge for driverless vehicles was 2004, and not a single vehicle completed the course. 7 miles in the desert, no one could do it. 2005, something like 30 vehicles. Almost everybody completed the course, and then Google bought them all.
Did they really?
Yeah, absolutely.
Oh, wow.
Well, maybe not bought them all, but what we saw was it was already close enough in scope for a long-term thinking company to buy them.
Yeah.
And that really put the cards down so that most all of the other major automotive companies started really investing heavily in autonomous technologies if they weren't already thinking about it. It got to the point where 2014, and by that time, by 2011, we had both had a simulated urban environment challenge and had leaped ahead to 2011 having autonomous vehicles doing test drives on the streets of Silicon Valley.
Yep.
And now I believe if you go to the right parts of Silicon Valley, you can call up a ride share and it's going to be an autonomous vehicle. And I haven't yet done that myself.
Likewise.
But it means that the technology is coming very close to commercial. And we've seen this with Tesla as well, saying pretty much their car's autonomous. It's just getting over that last little bit of, do we really have the regulatory and the social infrastructure to support switching vehicles to autonomy? Like, what does that actually mean? And we've seen this a little bit with the sudden development of the drone industry. And again, we saw that democratization of technology happen where a satellite, a space station, something that is exploring Jupiter costs trillions of dollars to build. And you only really get one of them. A Predator drone costs millions of dollars. And there's only a few hundred at best in the world. And they're highly, highly specialized. But then it's dropped right, start to get professional photography level drones that are being used in the cinematography industry or being used to do kind of surveying for oil and gas or other infrastructure projects. And they might cost a few thousands of dollars. But that's starting to come into the range where you say, maybe as a hobbyist,
Yeah.
I can afford this or want this. And well, we hit that tipping point a few years ago, to the point that I think a drone was pretty much under every Christmas tree the last couple of years, because they're so affordable. Naturally, the cheaper technology gets, quite often the smaller it gets and the fewer capabilities, but it allows a lot more experimentation.
Yes.
And we've seen this with phone technology. Those of us who are really old can remember when phones were tied to the wall and you couldn't move around with them. And then when I worked in a TV station, and I think we had like the first car phones in Australia, because, you know, hey, TV news, important people need to know what's happening. They were enormous bricks of things. It's, you know, like I said, it's just living memory here. And it's the
$4,000 for one in the 80s for
easily,
for a cell phone.
They were
huge,
absolutely huge. And you kind of fast forward and say, you know, 2006, the first smartphone. Now, in terms of figures, I believe 66% of the world's population has a phone.
We're getting there.
And in fact, it's replacing infrastructure in a lot of the developing world. So it's no longer purely a first world thing. And because of infrastructure problems, a lot of, I believe 3/4 of India gets access to the internet via their phone, not through any other way. So the whole kind of infrastructure step of going to cable providers and through the phone network, like that didn't exist, but it doesn't matter. Went straight to mobile technologies.
And all of the poles on the streets providing us with our phone signals and internet signals. Again, something that potentially Africa, India, other places in the world leapfrogged that step in development. So we're already so deep in this. We went, you know,
well, we're really just getting up to the point that you raised in the question, which was Kiva robots. And what we're starting to see now is the proliferation of what are still called service industry robots, because, you know, here's the key: a service industry robot, it's not in a factory like an industrial robot necessarily, but it's not a consumer robot. It's not in our house. It's a robot that's a business robot, basically. It's doing something in medicine, something in agriculture, something in logistics. And logistics is absolutely a hot area right now. And it started with Amazon's acquisition of Kiva Systems. And when a large company like that says, we actually believe that autonomous mobile systems will do a better job than building effectively a kind of automation infrastructure. So that's the turning point there. Instead of saying, well, if I want to get something from A to B, I have two choices. Either I hire a person and they walk it from A to B, and we pay, let's see, minimum wages are going up, and we're physically limited. We can't shift the factory to Vietnam or wherever the latest low-wage country is. We're doing it here, so we're going to pay what it takes. Or what else can we do? We can invest in building a conveyor belt that will continuously take things from A to B. And of course, the downside with that is it's expensive to put in and it's really difficult to change. You know, what if you suddenly want to shift it over to C? It's easy for a person to do that, but it's also very boring, very tiring, and it can be hard to get people to do a lot of these jobs. So mobile robots that can more autonomously follow different pathways, that is what the tipping point for logistics has been. And I see it as reshaping a lot of our industries. We're now starting to see mobile robots attempting to deliver food, delivering small goods inside of hotels, and in FedEx is just starting to use delivery robots. We see quite a lot of delivery robots in places like hospitals, and that can range from very large, hefty machines that are doing dirty laundry and doing food trays, and to very small machines that are taking blood samples to and fro the phlebotomists or the laboratories. Now, it turns out that that's a very, very high-skilled job, and in fact, anybody whose primary job is to interpret lab results and give you, you know, the right results, that's a highly skilled, highly trained job. And we pay a lot of money for that. But to preserve the quality of whatever they're looking at, very often we require that person to be the person to walk those results or those samples from the point of collection to the point at which they're being used. And that's a waste of a very skilled person's time. And this leads into one of the areas people worry a lot that robots are going to take jobs. And that's not really a good proposition to say you want to be a startup in robotics and you're going to need investment, and you go to someone and say, hey, I'm going to put all these people out of jobs. And as an investor, you say, well, where's the profit margin? Because people are cheap. It doesn't sound to me like you've really got a good plan. But if you come up to me and say, look, all of these factories have trouble filling this job, or farms are wasting 1/3 of their produce because they can't get sufficient people on the day that they need to harvest, or nursing staff. We're losing nursing staff faster than we can replace them, and we've got a 2-week backlog on getting results for all these expensive conditions and so forth. And we can fix that pain point. And it's because we're filling in the gaps where people aren't with robots and automation, rather than trying to replace a person.
Yeah.
And we've seen how stupid robots are. I mean, honestly, people are not going to get replaced anytime soon, but some of the bits of our jobs will be. So that is particularly the tasks that are the dirty, dull, dangerous ones. And the Kiva systems in robots are doing that job because the intelligent part of the work is discerning if the objects are the right objects and what to do with them, not walking the objects from a shelf to the packing box. So take the part that people don't like doing out of the job, and then you're much more likely to be able to staff the rest of the warehouse.
Yeah. So we're definitely gonna get into human capital, like you were ending with that. That's gonna be a great conversation. What's gonna happen with human capital, with automation? As we get there, to unpack so much of what you just said, I loved all the examples because they're so close to what we experience every single day. And I think, like you said, it started off with even the simple photo of taking a factory that used to assemble automobiles and replacing it with the arms that take pieces, move them around to the dangerous metals and liquid metals, all the other dangerous equipment. What was it? Dirty,
dull, and dangerous.
Dirty, dull, and dangerous. That's very important. And then we moved into productivity with dairy. We moved into productivity with other like logistic systems, with surgery systems. That's with intuitive surgical. That's really important. And many of us, especially our grandparents or our parents, are sometimes even having experiences with that equipment, and we might not be so aware of it. But now it's with the progression into autonomous vehicles and drones and all these other forms of technology that are slowly maneuvering their way into our existence, especially in large major cities where you actually see the vehicles that are going and mapping the roads almost on a daily basis. It's starting to be so close to us. So looping us back to the initial point, now they're more visible in our daily lives.
More visible, although it might not be directly in front of us. They'll be working with some of the people that we know, and we will have kind of a passing relationship. If we're, I suppose, right up on the top end of the early tech adopter scale, then you might have a robot in your house, not just a robot vacuum cleaner, but some other sort of robot, or you might have one in your workplace that you see, but these are still very early days. That's, I guess for me, that's at that end of the spectrum, and it's the social robot spectrum end of the scale, and we'll see those in shops and in hotels and in other places more generally before we're all likely to have one in our house, one or two in our house perhaps even. And this is a really nice field because I think right here in the service industry, you talked about robots for surgery. It's an interesting area because most surgical systems they're not necessarily multi-purpose. What we're finding is that each kind of part of the body has highly specialized surgeons and procedures, and it really takes a very specialized robot. And you say, well, what is the robot doing? It's very much augmenting the surgeon. The codes in medicine are so clear, it has to be the surgeon's control all the time. You don't have robots doing surgery. But why you use them is because they compensate for minute variations. And if you think about it, a surgeon can spend 8 hours performing an operation. It's very, very bad in terms of posture. And it turns out that when you operate, say, on somebody's knee or other parts of the body, the best position to get access is actually with the patient upside down. And as a surgeon, then you're getting the entire medical staff to try to operate from underneath. So those are things that if you could facilitate something like that, you can get the best possible outcomes. And yet our traditional model for surgery is the patient in one position, kind of flat on a table. With the use of robotic surgery, you have highly trained surgeons with the ability to see what they're doing at a position that might be quite different to where the actual tools and the cameras are. And it's such good fidelity in terms of the vision and in terms of the haptic feedback from the system that they can operate from here when the patient might be here and the operation is happening here. And so that's one of the really great things about it. The second is, so you're reducing the strain on the surgeon, and any sort of tremor or slippage can be
fatal in some cases.
And it can be partly eliminated through the system. You know, if you mark out the dangerous boundaries, you can kind of set markers, you can provide more protection than you could, and you can do this in a minimally invasive fashion. Because if you're only inserting the ends of the tools that you need, you can have a much smaller kind of incision than when you have to open everything up so that people can see what they're doing and to reach with, you know, larger, wider tools. So there's the consistency, there's the ability to prevent fatigue and error from the surgeons, and there is the minimally invasive kind of aspect of it. And you know, even beyond that, there's the idea that once you start to effectively add a digital layer to something that's a manual or physical procedure, then you can start to gain information about that procedure. Was it successful when it happened this way? And then let's share that information. So it adds another way of creating and effectively sharing additional value.
Yes. And this is one that's, again, very close to home because so many of us have parents or grandparents that are experiencing some sort of pathology over in their later years of life. And what more important way to understand the impact of robotics on an industry than directly with the health and the longevity of a family member. That's a really important, there's so many different variables you listed there are so important. And then do you have another kind of interesting one that you've been, you were listing so many as well with, even with delivering.
There are so many fields, so many areas that are starting to be.
Delivering goods to someone via FedEx, roboticized FedEx or UPS truck. I mean, we're talking every single field is being impacted by this, and we're seeing more of them. So the number is actually decreasing from 25%, or increasing. 25% of ones that we see now, maybe it's going up to 30 or 40% of robots that we actually see. You think?
It can be, but when we look at a car, we don't tend to think robot. Ditto when we look at a plane. And these days, most every new car, and definitely every plane, is a robot that just happens to still also have drivers.
So it's a hybrid, though.
It's capable of With cars, they're not all capable of full autonomy yet. I think technically planes are capable of full autonomy.
Yeah, they're like 99% or something,
yeah,
very high.
But we don't choose to use that yet for other reasons where we just, I guess, don't really have the legal insurance and social infrastructures to say, yeah, we're okay with, jumbo jets flying without pilots.
Yeah.
I think that we're going to see platooning when we're talking about trucks, planes, and cargo ships.
Platooning?
Where what we see is that the first vehicle has drivers, and then the second, third, and fourth don't. They follow the pattern of the first vehicle.
Sure.
So I think those are probably effective ways of using autonomous technology. And then once again, we might see it, but we won't go, oh, hey, look at the autonomous trucks. It'll be just like, oh, there's a road train. I mean, in Australia, we see a lot of road trains, and it's a mechanical linkage. Now we're losing the mechanical linkage in the same way that we've already got drive-by-wire in all our cars. So there is no longer a mechanical linkage between what we do as a driver and what the car does. That's already something that is more like a robot than we think.
Platooning, yeah. So they'll be following along digitally via software without an actual hardware person moving it along. The other part of the shipping industry I thought was really fascinating as well, logistics and moving cargo, because 90% of all world trade happens by sea via these massive barges and containers. So to be able to reroute logistically barges to different cities depending on the amount of goods in those cities, as well as just overall taking the already crew of a couple 2,500 people and saying we don't need the crew. The barge can go by itself and you don't need to be out at sea for this long. There's a lot of examples of this. It's so many different industries. How about we talk about human capital then, because you had mentioned it earlier. I think it's really important. When people come and come up with an idea about how they want to automate an industry, typically people respond by saying that, well, like you said, human capital is very cheap. How much is it actually going to cost to build out this hardware and software to be able to replace them? How much money can be made after so many years? But one more time, dirty, dull, and dangerous. Dirty, dull, and dangerous work that they're typically trying to replace is actually, in many cases, humans prefer to do something else, creative work or some sort of other problem-solving work that is more dynamic, that's non-repetitive, that's not dangerous, dirty, or dull. So it seems as though it's becoming more and more, human capital is moving in a direction of needing to be more creative and problem-solving, and something important to teach our kids.
I think that we need to do more investing in STEM education, but I worry that we say that that's where the problem point is, and our education system is a very slow thing to change, and we really need it to have changed already. But I think one of the things that we can do, as we saw with the Industrial Revolution around the automobile, an entire population shifted from the care and tending of the horse and the carriage to the care and tending of the automobile. And it wasn't that everybody had to suddenly skill up. There were comparatively gentle on-ramps in some areas, and it might be areas that we don't necessarily see yet because there's not yet a huge demand for people working in robotics. Well, let's say the demand for people working in robotics right now is for highly skilled people who can design, build, and program. I don't believe that everybody is going to need to have a degree in computer programming to work with robots.
Definitely.
Because look at what we've done with our phones and tablets, and every 2-year-old I know is highly fluent in operating phones and tablets. And I know that some of the companies that were making early robots in areas like bomb disposal robots, oddly enough, one of those companies went on to make the Roomba robot vacuum cleaner that's so popular, but they also made robots for the army, and I think one of their robots was thrown out because it was too complicated. You opened up a suitcase of all of the controls to make the robot work, and when they were showing it to the army, they just said, this is way too complicated for the average infantry man to use. Come back with something that works like an Xbox controller, because everyone can operate an Xbox controller. And the point was, I think, a really important point for everybody building robots. It's about usability.
Yeah.
You know, sure, you can build in all of these functions and have all of these controls, and the thing is, if no one uses it, you get no results out of it.
Even the intuitive surgical controller looks a little bit like an Xbox controller.
Oh yeah, and it's a remarkably sophisticated device, but it gives you feedback so that you can feel what you're doing and how it's working. You know, it just makes it very easy to operate it.
Usability.
And the usability is the key thing, and I think that before we worry about we're going to have an entire population that is going to be out of not just jobs, but out of the ability to have jobs, I think it is so wrong. I mean, first off, every robot that I've been around has tended to need a person to take care of it. And that's not always highly skilled operation. Quite often it's a get it out of the corner again, it's not fitting properly onto the charge plate, see if there's something stuck in the wheels. I think we're going to see pretty much a standardized job for every couple of robots in the wild is a robot babysitter, basically. You know, like a robot driver, just in the days of the horse, you know, because they kind of have minds of their own. I mean, perhaps literally they do. They don't have autonomy, but they operate in a way that we think is intelligent but can get them into all sorts of trouble. One of my robots is particularly fascinated with their reflection in the oven as they drive by, and they're supposed to be zeroing in on people or other objects, but that's sufficiently interesting so that it stops. Oven, oven, and you're like, no. So there'll be a job doing that, and there'll be a job possibly controlling and getting the results and the readings and just actually moving them from place to place, because a person can move from one location to work to the next location, and that is a highly sophisticated task. I mean, can you imagine if let's say it was a cleaning crew, a robot cleaning crew? Well, you're still going to need the robot wranglers to get them into one place and then move them on to the next place. And I think for me, that's where I see the human capital coming back in, particularly with the opportunity to make money off your skills with robotics. One of the jobs that a lot of people will have had up to today is, say, painting or sanding or testing surfaces on all sorts of infrastructure, you know, being strapped into belts and taken up on the bridge, on tanks, on ships, on the sides of skyscrapers. Now, most of that's non-automated work. It's quite a dangerous job, and yet we have two people up in those little pulleys up and down the sides of buildings. Now, what I think is going to happen is that those two people are going to stop washing the windows, and they're going to end up on the roof or down on the ground driving the robot that's washing the windows and taking it down when it needs to clean and change the pads, swapping the pads, putting it back up, and then packing it away when, you know, the day is over or they move to a new building or a new job. And I think that's the key change that's going to happen, is it's an extension of the power tool, if you look at it that way. So we've gone from a period where we had carpenters, for example, and everything was being done with human power. And then we added power tools. We didn't really take carpenters away. We gave them the ability to be more productive and to operate more safely and more efficiently, more effectively by adding power tools. Now what we're going to do is, instead of driving the power tool by hand directly and, you know, chopping your fingers off, we're going to give you the ability to kind of remotely operate the power tools, because that's the autonomous robot.
you're bringing in this really important short-term step that is typically passed over.
Yes.
You're totally right. So many conversations about robotics and AI go on without even, and human capital go on without even considering this step that's happening in the next 5 years. The step that happens in the next 5 years is that humans will still be engaged in some sort of way with the robots. Like you said, a caretaker, a driver to the different destinations, someone that looks at over all of the different data sets and logistics that are actually going on with the robot, packaging up that data, making it applicable to people, all that kind of stuff still going to be needed in these near term years. And so this is the kind of retraining that we'll be doing with human capital in these next few years. I think that's really crucially important to understand.
And I believe it's retraining that's going to be doable, that can be done through online training, through self-motivated people. What I love is the idea that instead of, making it this really horrible retraining, is to make something really usable, you capture things that people already do or like doing. And I think there's quite a strong element of video game playing in our operations with robots.
Yeah.
And so, on the one hand, you can be really, you can get a lot of status for your ability to play video games. Now, that's going to translate over. You can be really, really good at controlling robots, and that's really leveraging skills you're getting having fun. So I think that there is some really good opportunities there in the future.
Yeah, you're so right. Especially with video game play, I feel like that's something that augmented reality is coming up. I mean, that's a really good way to get trained into using a robot in a new way, helping that robot learn over time. Okay, so human capital especially looks like it's going to go through a change where we're engaging. It's going to be like a little more of a hybrid sort of interaction with the robot in the next couple of years.
Yeah.
What should we be teaching our kids? You said earlier you were talking about education and STEM being so important. How does their teaching style to the child, and how do the communities and the teachers, how does our teaching style change to the kids as they're 5 years old, 10 years old, 15 years old, to kind of get them ready for this change?
That's, again, a really good, and it's a really hard question. Sometimes what happens is the education system is too slow to respond to the changes. I think what the education system does very well is it knows the importance of standardized learnings. I mean, these days we all learn to read and write, and I think it would be a great problem if that stopped.
Correct.
Okay, I think that what that does is it gives us the foundation tools to learn anything else in the future.
Yep.
And the maths that goes with that, I think the key thing is to teach critical thinking, not purely logic, but that real kind of problem solving. How do I know that this is true or the right way to do something? You're going to be faced with so many choices in life. I think the key thing is the ability to learn how to keep, not just learning, but how to make decisions based on the best evidence that you have in front of you, and how to recognize some of the things that we have cognitive biases towards. And that's where statistical thinking is, it's an element of math, but to me it's also an element really of psychology. It's understanding why people are, glass half full, glass half empty, why certain things will make us think it's half empty and other things will make us think it's half full. And we will make decisions based on those things, whereas if you stopped and evaluated them, you might really change your mind. So I think that kind of cognitive skill is key, and I believe that schools are doing that and can continue to do that. I do think it helps if schools are showcasing technologies, but I don't think it has to be an extreme rush. I saw schools in Australia rush to get digital whiteboards in, and that turned out to be a technological fad that, to my mind, was a great waste of money. Often schools get technology and they do not invest in the training and the support that's needed to keep them going. And I have taught robotics in schools, so I know that sometimes You know, we do a lot of fundraising to get kits of robots, and then an outgoing parent says, what happens to the robots we bought 2 years ago? And it turns out they're in the back of somebody's cupboard and nobody knew. So there were all of these things that if you don't have advocates, really active advocates within the school itself, then you have this turnover and someone comes up with a new program and it's like, wow, this is fantastic. And then 2 years later it's forgotten, it's at the back of the cupboard. I do think, though, there's been a move to getting 3D printers into schools. And what I find great about that isn't that they work very often at all. And I don't think that, I don't think they integrate into the curricula hugely, but I do know how compelling it is when kids watch something printing in 3 dimensions. And then if you can match that back to the idea that they can be designing things on their computers or phones or tablets, and you know, you're transforming something from an idea or photos in real life into manipulatable kind of information that can then translate into something that a machine works on. And to see that happening in 3D is so much more fascinating than just seeing like 2D printers printing. You know, it's like type words, have things printed out. It just doesn't seem to carry the kind of epiphany. And I have to say, I would call it an epiphany. I've watched people's faces when we've done kind of show and tell days with our makerspace and other things like that. And they're like, oh, robot, robot, robot. Ooh, what's that? And it's been, oh, that's a 3D printer. Like, you know, old hat, technology, really. It's an old technology. But the first time someone sees it happening, it changes how they perceive their ability to interact with the world.
Yep.
And it's that kind of shift that I think is the best thing. You don't need to have one in front of you all the time,
Correct.
Just to change how you think about what's possible.
Yeah, that's really well said. It's expanding the mind to new dimensions, new areas of perceptions of how to see the world and how you can then impact the world through these different technologies and tools that we've built. It seems to be that having a parent help a child gain access to these new shifts in perception, these augmentations, ends up changing that child's perspective for the better and can launch them into this new age of technology. Ron, question for you. What do you think about the progress with robotics and technology that we're currently facing?
What was the question?
What do you think about this progress with robotics and technology that we have? What do you think about human capital being changed?
What do I think about it? I think as soon as we realize that we are a magnificent robot in ourselves, then it wouldn't be so overwhelming. I think what's happening right now is what we're becoming is we're just revealing what we've already been. Sort of like, oh, you will become gods somewhere written. You know, did Satan write that somewhere down when we took a bite of the forbidden fruit? I don't know, but that's what I think about this time that we're in and who we are and what we're creating in a robot with artificial intelligence. You know, we have artificial intelligence too. We're not as smart as we think
We haven't
we are.
quite unlocked our own divinity. We haven't quite gotten to the point where we can fully actualize ourselves in the full capacity across all these different people in the world. So to Ron's point, I feel like that's something that's very true.
And I mean, there's two sides of that I really love. One is that I actually think that we have less artificial intelligence and more intelligence augmentation than that's really the key of what we're building and doing, is that it's extending our human intelligence all the time.
Yeah.
And so it's better. In fact, there was kind of an argument back when the term AI was coined between, is it artificial intelligence or is it IA? Is it intelligence augmentation?
Yeah.
And you know, I think intelligence augmentation is exactly where it's at right now.
Yeah.
And yet one of the things, when I was a kid, I was the complete rockets and robot geek, but my ambition was to be an astronaut. And you know, what I passionately wanted to do was discover the first aliens. And that's what I feel that I'm doing when I'm working with robots, particularly the robots that are becoming social robots that we're having interactions with, because it is a constructed intelligence that is not human, that is very different from human intelligence in so many ways. And to me, it's actually the perfect practice mission for discovering life out in the universe, is to, well, on the one hand, we're creating this, which is kind of the divinity, the aspect. We're able to have the tools and the dreams and the ideas to do this, but it's still quite mysterious how robots work, where we're going with them, and the human mind. And this is a point where we can, whatever we're building in our artificial systems, we can use as a model for what happens in the human systems and how they differ. And you know, this has happened quite, in fact, all through the last 50, 60 years, is we've modeled our ideas of biological systems, and we've modeled them mechanically. And then we've seen how that works, and we've revised our models. So it's the whole field of biomimicry has been creating machines to mimic life, and then discovering how we have now a better insight of how life works, how the biology works.
I'm glad you brought up intelligence augmentation, because that's really what is happening in so many different ways. And I think once people kind of get that grasp of how everything that we've chatted about over the last half hour, 45 minutes, that is augmenting our intelligence, or intelligence augmentation, and the idea of an artificial intelligence, maybe we should at least touch on this, because it seems to be a topic that so many people are at least wanting to discuss. Is in 20 years, where do we see our relationship with the general artificial intelligence, one that has the ability to dynamically shift across industries or across interacting with humans, that can take a goal and execute it creatively? Do we see that as a potential existential threat to us?
I think there's a couple of things here. I think on the kind of loosest definition of an artificial general intelligence, I'm a bit of a pessimist. I think it's at least 30 years out, like definitely post 2050, at least. And yet I can see some seeds of it in development right now. But that's why I said we're really at intelligence augmentation, because what we have is a lot of niche artificial intelligence developments, and there isn't a generalizable thread across them. And indeed, what we usually mean when we say AGI, or artificial general intelligence, isn't just the ability to kind of transfer knowledge from one domain to another, or to learn in multiple domains. And they're each important and difficult steps forward. But we take AGI to mean also a kind of theory of mind, the sense of a self. But I would say that's still only one of the steps towards that. We leap straight from going, it has a mind, to it has autonomy, and to it has desires, and to it's going to kill us all. And you know, I think we have to kind of back and look through all those stages and say, we can probably develop something that has a theory of mind. So does a raven, you know, but outside of Alfred Hitchcock's The Birds, we're not really much of a threat from ravens. Knowing that you are a kind of a unit doesn't necessarily mean that you consciously also think about your choices or desires, or have that step of autonomy and agency. And then desire, motivation, is something that's highly biologically intrinsic to us. And I think there's no guarantee that we have that in an artificial system. You know, some people will argue that you can't have mind without having motivation, and other people will say those things can be separated. I think that we could get a kind of theoretical mind without necessarily having motivation. And because it might not be embodied, or if it is embodied, and I do think embodied cognition is perhaps the fastest way of learning, which is back the step before, you know, generalizable, learning, then AGI. If it's not a biological body, is it going to have the desires inherent to it that make us as people have such passions, desires, and urges? And then the next one is, if it did have all of that, if it had a mind and had desires, why would they necessarily be in conflict with us? Would they perhaps recognize us at all? I mean, would we be competing for resources? I think there are so many places that could go where insects have very sophisticated civilizations. Other different levels of life are incredibly prolific and strong and clever and adaptive. Yet we are operating on such different levels. We're not under, you know, we can operate in parallel or in symbiosis. And so to go straight from artificial intelligence all the way up to is it a threat to us is making so many leaps. I can't see a pathway there.
There are so many leaps, totally agree. Like you explained, there's so many steps before we actually get to that general intelligence. It'll take us quite a while to get there. We also have ways to map the human neural architecture and then understand the architecture of a machine and the way that it could potentially have desires and all of this stuff that would then give us greater insight into how it can get to that point. Do you feel as though the conversation on a global level, or even the geopolitical struggle that we currently have between nations, China, the United States, in terms of how many people are striving to be the first to achieve some great goals in artificial intelligence, is this a naturally important thing to have markets sort of competing with each other for innovation? That's a good thing. Should we also potentially have some sort of social contract between one another to want to keep these on closed loop systems so that they don't escape via software into the world? Where do you stand on the conversation?
I think we've already kind of taken most of the world online, and it is very hard to firewall. So I don't really know how we would address that. I think that globalization is one of our biggest challenges, though, and that's really in terms of our broad political and economic wrapper. We've turned into a global state, and yet we still have a very geographical infrastructure. And I think that's inherently causing a lot of tensions. I think we have got a lot of a tendency towards capitalism and microtransactions. And our technology can help with that, but I still don't know how that plays out in the face of this conflict between our kind of current globalized pathway and our, as I said, our geographical infrastructure. And that's where Norbert Wiener said back in 1964-ish that the future wasn't going to be a comfortable hammock that we could lie back in and be waited upon by our robot slaves, but it was an ever more demanding struggle against the limitations of human intelligence. And he was the grandfather of cybernetics, of man-machine interactions. And what he saw as the limiting factor was the human structure and the human, I guess, imagination and intelligence. And I think that that's also, you know, a limiting factor is also a governor. It's a controlling factor as well. So I think that that's both a positive and a negative in both.
Yes, so this is good. This is so much to unpack in a conversation about ethics and I mean, just even as simple as what do you think the human intelligence interface is going to look like in terms of ethics and morality? Who do you think is going to be programming that? Do you think it's going to be the actual company? Do you think it'll be a government, United Nations? Where do you
I think we've already gone well down the pathway of having companies make these decisions rather than governments. I do think it's great to see a sudden increase in the number of international ethic bodies talking about AI, autonomous systems, and robotics, and saying what are the ethical principles and guidelines that we need to consider, and that this is being informed in a multidisciplinary fashion, because we need to have the input from law, from policy, from insurance, from economics, but also from what's actually possible and where the threat points lie. I think we have seen issues around algorithmic bias and nudging both in a very little way and in a really kind of steering our economy type way. So when we have algorithmic trading, for example, and that escapes beyond human speed of reaction, through to what happens when we embody the algorithm in a case, in a robot. And that can range from what does that mean in terms of physical harm, through to what does that mean in terms of stereotyped interactions and behaviors. And it does raise all of those quirky questions like, what if we fall in love with a robot? But even before we get to those points, what does it mean when we stereotype our robot occupations? And we've already done this with our voice assistants. So I'm aware of 6 major voice assistants, economically speaking, in the world. They're all female. Okay, and we were trained for this even before when our GPS voices, you can change them, but they were default female, and very few people change them. Our psychological studies show that we respond differently to male voices and to female voices, and this is across a whole range of ages and demographics. On the whole, we treat a male voice as having more authority, and we're more likely to respond quickly to a male voice. And we treat a female voice as calming or more compliant. So we're less likely to be irritated by a female voice. But because of this, there is a tendency to use female voices unless you need to make a command. And I don't know if it's like this all the time, but I was in London recently, and the famous London Tube announcements to mind the gap. On every train ride that I was on, the female voice would say, and we're now approaching something Heath Station. It's our second station on the yellow route, and we'll be moving to the next station soon. And then the male voice would come in and say, mind the gap. And it seemed to me to be absolutely down the lines of when we're telling you to do something, we use the male voice. And when we're giving you information and helping you, we use the female voice. And the thing is, we've been struggling for equal rights for hundreds of years now, and we're just starting to get closer in many professions, and yet we still have vast pay gaps and still very difficult to get women into certain areas like, venture funding or politics or the high-profile areas. So is this going to set things back? Because we're training our systems to behave with gender stereotypes, and then we're repeating and replaying all those gender stereotypes. So everyone's going to grow up with this whole, here, can I help you? Now do this kind of thing.
Fascinating.
So that's what worries me, and I think it's perhaps one of the mildest things, yet it's the most pervasive thing.
Yeah. I'm totally blown away by that, because without even considering how it's gonna impact children in 5, 10, 20 years, we're just doing these things. I guess similarly to what we were discussing earlier with people automating this work, we think it's going to be good for everybody down the line. We don't necessarily know how well it's going to do for certain industries. What's going to happen with the first accident with autonomous vehicles if someone dies? What's going to happen with the first incident where...
And that's happened.
And who's liable when the software that's parsing an X-ray or a PET scan says that there is something that's wrong with the body when there isn't, or when there is something wrong.
And it's not detected,
not
false
exactly.
positives, false negatives.
Yeah.
And the most challenging one is, because these systems are complex, we're building in a modular fashion. So you'll have one company that is doing, for example, the computer vision, and one company that's doing the hardware and bringing it all together, and one company that's provided the operating system, and another company that's perhaps provided the data training sets that was then incorporated in the computer vision, that was then packaged together by these developers as part of the navigation and behavior patterns that was then put together in these systems. And how do you find out where the problems were?
Yep.
How can you even see them if they're coming as
modularity,
modular and proprietary kind of software layers?
Yeah, that's also a crucial point. So, okay, let's go through some of our simulation questions. We already have, but let's ask you about the current state of so many people having so much less than so many others. So if 4 billion people have about as much wealth as the top 8 richest people, this even though the people that are really poor in the world are slowly going up, it's really good. We have the 8 that are kind of going exponentially up with again augmenting their senses with robotics, AI, genetic engineering, brain laces, space colonization, all of this stuff. Where do you see the future of that gap of wealth inequality, and what are your thoughts about it?
I think that we're approaching not so much an industrial revolution, although that is certainly the case, but we're approaching another information revolution. The acquisition of language was such a significant point for the human species. And then the ability to read and to share information. I think the political upheavals that happened around the time of the printing press and the dissemination, the broad dissemination of information, and the growth of our ability now with almost universal education, it's upended the world. Now, if 66% of the world now has access to a phone, and these days that means access to the internet, that last third of the world is going to be picking up on this really quickly, even if it's only at 1 or 2 points. I think we've reached a point now where the poorest societies have access to, at the minimum, radio and television, and most likely access to the internet. So it's no wonder that we're seeing this, desire to migrate to other parts of the world if your life is untenable where you live. You've seen that there are other alternatives. And I think access to that information is going to potentially allow a lot of new developments, new technologies and new ways of developing technologies that could shift some of this, incredible disparity in wealth. Right now we are privileging a small set of the population, but I don't think it's a given that you have to become a tech billionaire to suddenly change things. I think that, what if we give the information tools to people that have incredibly strong business and inventiveness, and allow them to start to perhaps remake their economies in ways that take better advantage of the things that are still accessible as resources. And I'm using the word resources really broadly. I am not an economist, and so I don't want to stretch too far there, but when we look at where are there social, technological step changes, then I think that global access to information is the real revolution that we're going to see. And I just hope it means that we get a better distribution of the world's wealth.
Yeah, I think so too. I think as people become more competent, they typically figure out that they want to give back in some way, shape, or form. As they become more wealthy, they figure that out as well. So, okay, how about, are we alone in the cosmos? What do you think about that?
Not if we build robots. And that's the short answer. The longer answer is we also need robots to go out and explore the cosmos, because it's a very long trip in dangerous conditions for people.
Yeah.
So perhaps robots is win-win.
Yeah, so you think, yes, send robots out to go to explore for us, but do you think that we are alone? Do you think life has evolved on other planets orbiting stars? Some sort of life?
I feel like there has to be life, but I suspect it's so different to us that we don't recognize it. And I think that, I mean, I would love there to be human-like or, you know, communicatable, compatible type life out there. I think that would be so, for me, you know, that's my childhood dream. I think it would be an amazing experience, but it's also a really arrogant view that our particular life template is the best, most replicable one. It's interesting because there are some people who will theorize how when you're basing, you know, a carbon life form, you are eventually going to end up with something like us, as if we're kind of the inherent top of the tree. But I would think the more we learn about our recent history, the more we realize that perhaps we were just the most bloodthirsty of the branches of our recent trees, and we're doing a pretty good job of wiping out all of our competition. But what that means is that our mindset is flawed when it comes to saying, what does other life look like? On the other hand, I also think that there's signals in the electromagnetic spectrum that would almost certainly be sent out by any sort of compatible, communicable life form, and there's so far no signs of those, so that doesn't bode well. But I think until we've developed some form of traveling at or above light speed, that perhaps just the sheer time lag means that we can't interpret anything.
Mm-hmm. There's always a good conversation about cloaking as well, people figuring out how to quell those electromagnetic signals, all that good stuff. So how about the question of if we're in a computer simulation? What do you think about that?
Who would bother? That's kind of, you know, I just think it's so incredibly beyond. It strikes me as a thought exercise more than something with any reasonable pragmatic likelihood. And maybe that's an arrogance there that I don't see. But I think it's arrogant to think that we're in a computer simulation, because it's kind of, wouldn't it be rather boring for whomever had the ability to create it?
Or could it be the greatest thing ever, is to simulate a universe and then observe how all of the different life flourishes across the stars?
And perhaps I'm still a pragmatist at the end of the day. I mean, if I don't know, does it affect me? You know, I do think the Turing test idea, which is if you can't tell the difference, is there actually a difference, is still quite a valid way to look at things. And if I can't tell, then how is it going to change my world in terms of my behavior?
Yeah, if we do come up with a way to actually figure it out, I think it is potentially one of the most profound things that we could uncover. But like you said, as a thought exercise in general, it's really important. Expanding the mind to new dimensions of thought and thinking. We were discussing that earlier and how important that is. All right, how about, as a last question, what do you think is the most beautiful thing in the world?
Oh, I immediately thought of all those gorgeous pictures of space and all of the other celestial bodies, but in my life, it's things like being able to go for a walk on the beach and know that I have people in my life as well, and just the knowledge even without seeing them.
Yeah, yeah. So everything from observing the cosmos all the way to the walk on the beach and having people that you love that love you in life.
Yeah, I think the incredibly pragmatic experience of being a person alive in this world, and to me, being a person means being connected to other people, and this world is such an amazingly beautiful place. You know, I like looking at the stars, but the world is really quite overwhelming as it is.
Yeah. Life's too short to be able to see it all and experience it all.
Gosh, yeah, yes.
Yeah. How about we do one of these? This is a nice little a fun box full of 100 questions. I have a little guide sheet here to, let's see here. Do you want to do sex, love and relationships, personality and emotions, friends and family, culture and taste, work and money, travel, life and death, self? What category?
Wow. How about life and death?
Life and death. Okay, that's the.
I kind of picked studying robots because I said, if I'm going to study something and spend all that time learning and thinking, I want to make sure that it's something that's a really important question in life. And all the way back through to saying, you know, what were the Aristotelian and ideas of what are the most important questions in life? So let's go for life and death.
Let's do life and death. Let me get the. Oh, here we go. Here's some of them. All right. All right, we'll have you pick from these.
Okay.
What's the question?
What are the best features of middle age? Can we have a second read on that?
What are the best features of middle age?
This is kind of a little bit ambiguous around life and death, isn't it?
Just throw that card away.
What do you think,
Well,
Rob?
I kind of like that. I think technically I'm middle-aged.
Just toss that one away.
And I think you get the best of both worlds, as it were. You know, you're young enough and agile enough to be able to experience all of the things that in youth were totally confusing and bemusing, and you've developed your sense of self and who you are. Yep. Although now I find the worst thing of middle age is the fact that I stop and I count and I go, unless we fix this real soon, I'm approaching the halfway point of my lifespan, and that's not comfortable.
Yeah, so on one end you got the beauty of youth, and on the other end you got the beauty of death, and you're trying to scarings of death. Let's do one more for fun in that same category.
How could older people be valued more?
Ooh, that's a good one. How can older people be valued more?
Do you know there are a lot of World of Warcraft guilds of older people? And I think that's a super, I can't wait to retire. I'm going to totally video game myself into, you know, but this comes back a little bit to what I said about there are a lot of pathways to employment through new technologies that can be fun. And I think we've got an opportunity to reframe what work is. And if the essence of being an older person is that you are limiting your physical mobility and perhaps your fine dexterity and those kinds of things, then what if we have technologies that allow you to, and I don't want it to be work as in slave driving type work, but things that allow you to connect with other people without having as much of a physical component.
Correct.
And things that could allow you to have positive impacts on other people through that, where you might have, you know, I do volunteer work, I do some things like that. Maybe I'm not going to go and do it the way you can go and plant trees, or, you know, that's a manual task, but, you know, it's fun and you do it with a group of other people. Maybe we can switch some of the tasks like that to a virtualized environment, or where you're teleoperating robots, or where you're dropping in to respond to queries that people who are visiting museums have about something that's a passionate area of your interest. And you go, look, I really loved, you know, back in New Zealand, I remember this, and, you know, I'd love to be there, but I can't physically. And maybe I can still participate. So that's a long way around to say, can we create a more participatory lifestyle
Correct.
to value
Yeah.
older people more?
That is beautifully said. I totally agree with you. Even though the physical body may not be able to be in those locations, the mind is still at least able to function and provide some sort of engagement with the world and shed its wisdom into the world still. So I'm totally on board with you there. And that is a really good full circle to all of these great technologies that we've been discussing, how they are being augmented through robotics and through code. I think that some of the key highlights are, even though all of these technologies, and Ron brought this up as well, even though these technologies are proliferating into our world, it's still really important to somehow remind ourselves to tune in and be introspective into reminding ourselves what purpose we have, what impact we want to bring to the world, and furthermore, bringing that to our children as our children grow into the world. Really important to, like you mentioned so many times, figure out exactly how they can be introduced and have their minds expand to these new dimensions of 3D printing and robots, and have them see it and then feel it and then think about what they want to do with this technology moving forward. I mean, from the beginning of the talk, you listed so many fields that it's already in. We definitely recommend everyone to just go and look it up, see what Kiva Systems does in Amazon warehouses, see the intuitive surgical robot, go and get a little tiny drone for like $20 at the store. They're so cheap now. You can just fly around a little cheap plastic one and go play with it and feel it out and see it in action. Andra, this has been such a pleasure. We appreciate you so much. Thank you for coming on.
Oh, thank you so much. I have to say, it's so nice to chat with you about all of the things that I think we're both really passionate about, which is let's understand where technology is going in the future with the goal of steering it to give us the best possible outcomes.
Exactly. Yep. And that's why we have conversations like this.
Yeah.
If we can get more people talking about technology, helping steer humanity in the best possible directions, I think we'll have more creativity, more diversity around understanding how it can do so and actually bringing that to fruition. So big shout out to you guys at home for tuning in. Thank you so much. Again, if this content's powerful, useful for you, give us a like, comment, subscribe, share it with other people, become a patron. On our Patreon, you get access to exclusive Q&A with guests, live event info up ahead of time, exclusive content as well. So check us out on Patreon. Ron Vargas, our director and producer, thank you so much. And this has been a lot of fun. Let's do this again soon. Thank you, Andra.
That was great.
Thank you so much.
Thank you.
Such a pleasure.